Welcome to another episode of the Contractors Innovation Podcast. Today, my guest, soon to join us, is Paul Beckwith. Paul's got quite a following himself and is a part-time professor in the University of Ottawa. I'll let him introduce himself. Yeah, tell us a little bit about yourself for the benefit of my audience.
I'm a climate system scientist. I've taught climatology, meteorology, oceanography, mostly at University of Ottawa, physical geography at Carleton. I'm a climate I say climate system expert because many scientists are very focused in narrow fields, but I like to look at the overall climate system. And on my YouTube channel, I'm approaching a couple thousand videos. I try to generally put out about 3 a week. I take peer-reviewed science papers and try to explain them in everyday layman's terms so people can understand. So I'm trying to educate people on climate, but also other areas as well. I look at AI stuff and lots of different, mostly science topics, but there is some other stuff. So I'm very interested in Roman concrete versus the concrete that we have today. Um, so basically, the lifetime of today's concrete, the service life, isn't very long. I mean, it's basically decades. You might reach 100 years. It depends on how and where it's used. Of course, concrete is ubiquitous, right? It's everywhere in our society. I mean, our society is built up on this. So, in general, buildings, infrastructure can last 50 to 100 years. Residential flatways like driveways, patios, sidewalks, 25 years to 50 years. If they're well designed, well built structural elements, they can last maybe 100 years. In favorable environments, they can last longer. But the key factors that limit concrete, and concrete, it produces a lot of emissions, a lot of greenhouse gases, so it contributes to climate change. So anything we can do to get longer lifetime of concrete would result in lower emissions. So the key factors, you probably are aware of these things, and then maybe I'll get into some stuff if you're not. But the key factors that limit the life of concrete is the environment, like freeze-thaw cycles. So like, where we are in southern Ontario is one of the worst. It's one of the hardest on concrete structures in the world. Romans had generally warmer weather. We think of them, in warmer climates without the freeze-thaw cycles. But it's also the de-icing salts. Moisture gets into the concrete, aggressive chemicals, and all those things accelerate the cracking or spalling of concrete, especially in climates, like I said, like southern Ontario. So the design and materials of the structure, the concrete is crucial. Like, you basically and it determines the strength of the concrete, like water cement ratios, the admixtures, all those things, any rebar or other materials to increase the tensile strength of concrete. All of these things affect the durability and the corrosion resistance. And basically also, of course, the construction quality, the placement, compaction, curing times, the joint detailing, all of these things, if they're not done properly, it can lower the lifetime drastically down to 25 to 40 years for structures, exposed slabs and things. You see some new builds that were done around 2000 and they're already showing severe corrosion. There's a parking garage close to me in Ottawa. I don't know what they did wrong, but they've had to redo it like after about 10 years even. They've had to redo a lot of it. So it was just built poorly. And then, of course, maintenance, sealing. Do you have timely crack repair, drainage control, avoiding harsh chemicals? those can add decades if you maintain properly the concrete structures. You can get decades to their lifetime. So the main reasons for failure, I guess one of the biggest, probably the biggest reason, at least in our neck of the woods, is rebar corrosion. So rusting rebar, because when you get the iron oxide forming on the steel, it takes up more volume, so it can push the concrete away, causing cracks, delamination. It's a very common end-of-life mechanism in modern reinforced concrete. And then surface deterioration. I've mentioned the freeze-thaw damage. With climate change, changing extreme weather events, we're getting a lot more freeze-thaw cycles than we used to. In most winters, this one's an exception. It stayed pretty cold, very few freeze-thaw, but we do get some still. Scaling from salts, abrasion from traffic, all those things can reduce the performance until, it's more economical to replace the concrete rather than try to repair it. Now, I mentioned greenhouse gases, emissions from concrete. So concrete's, of course, a major source in our society of greenhouse gases, mostly via the production of cement. So about 8% of global emissions, CO2 emissions are from concrete. Most of it comes from making the Portland cement, which is a binder in the concrete. So for every ton of cement, we emit about zero point 0.8 to zero point 0.9 tons of CO2. Where does the CO2 come from? Well, we take the limestone, calcium carbonate, right? We heat it up, we make the clinker. It heats up at about 1300 Kelvin in some sort of furnace. And those furnaces are typically powered by fossil fuels, so that produces CO2. But then the chemical reaction of heating the limestone releases CO2 directly as well. So how much? Well, 400 pounds of CO2 or 180 kilograms is roughly released per cubic yard of concrete that's of the cement in the concrete, and it's mostly the cement. I mean, there is aggregate that we add, right? Crushed rocks or cements or crushed rocks or stones or whatever. Most of the CO2 emissions from is from the cement itself. So the emissions scale with the amount of cement that you have in the mixture typically. So how do we reduce CO2 emissions? Well, you can try to use low carbon binders. You can use other materials to replace some of the cement. So you can use things like fly ash, slag, um, different different clays, calcified clays. There's one called LC3 to try to reduce the amount of clinker. And we could maybe go down with some materials, some methods, cut CO2 per ton by about 40%. So instead of zero point 0.8 to zero point 0.9 tons of CO2 per ton of cement concrete, you can go to maybe half of that, but then you might be sacrificing on strength or some other issues. So lifetime, we're making more efficient kilns. Electric kilns is an idea. Have cleaner burning kilns so that we don't have those fossil fuels burned to heat the limestone. But the biggest thing is if we could extend the lifetime of concrete that we structure in our society, we could greatly reduce emissions. So this is where we come to Roman concrete. So I went to the climate conference in Glasgow after COVID ended in, I guess, 2021. And I visited the birthplace of my mother in Bonnybridge, Scotland. And she was born there in 1932. She's 93 now. And just up the road from where she grew up are Roman ruins. They have, just up on her very street. It's a small village in Scotland. Their claim to fame was a brick factory, a brick kiln, which is where her dad worked for many years, and many people living there worked. over the years. But up the road is these walls and bases and earthwork. So there's big, huge sort of hills in the soil, which is a site of Roman ruins. They've done excavations there. These Roman ruins, this Roman concrete, can last thousands and thousands of years. So typically, in this particular ruins was like 2,000 years old, walls in perfect shape. So why is the concrete still around? Why did it last so long? The Romans built structures in the ocean or on the coastlines that then got submerged at the end of the last ice age. And those structures are like 5,000 years old in seawater. Well, what is Roman concrete? It's a lime and volcanic ash-based concrete. So it's extraordinarily durable. As I said, many structures are still standing thousands of years later. And one of the reasons is two main factors, self-healing properties. So you get a crack in types of Roman concrete, and the crack could actually close up and recalcify. So how does that happen? Also, there's new studies that show that over time the Roman concrete increased in strength and durability. The Roman concrete, or so-called Opus Caementicium, they used mortars of lime from heated limestone. They mixed it with volcanic ash, and they combined it with stone or brick aggregates. And it was often the water in the mix was salt water. We're paranoid of salt in concrete now, right? Because it just shortens a lifetime. But the Romans figured out how to take salt in the concrete to their advantage. So basically, for their marine structures and coastal works, they used the volcanic material. They produced the concretes that hardened even under seawater. So they'd pour it; it would harden while it was in place. It wasn't made on the coast and then put into the ocean. It was often just poured in place in the ocean, and it did harden even under seawater and lower temperatures, and it formed these very rare minerals within. So we've analyzed this concrete. So why was it so durable? Well, the seawater reacting with volcanic ash and lime, it gradually forms these very rare crystals within the concrete. Some of these crystals, like there's some names like aluminous tobermerite or phillipsite. These crystals form within the concrete, and they would basically stop crack propagation, and they would strengthen the material over time. So many of these Roman structures, like harbor piers, became stronger as they age because instead of weakening like Portland cement type concretes that we pour in the ocean now. So what are some of the chemistries involved in these concrete strengthening over time? There's a couple things like they talk about hot mixing and self-healing. So new studies show that hot mixing with the quicklime or calcium oxide mixed directly with volcanic ash, which are mostly small glass fibers, if you like, and with an aggregate and water, they generate high heat during the curing process. And that high heat can rapidly cool, and it leaves these so-called lime clasts or imperfections within the hardened mortar. And this lime within the structure is unreacted. Okay, it hasn't had chemical reactions yet. So these clasts, they act as a reservoir of reactive calcium. So when a crack forms in the material, seawater enters, you get these new calcium-rich minerals precipitating out and filling the cracks. And that gives the concrete intrinsic self-healing behaviors, if you like. And this is very, I mean, then you have to ask, how the hell did the Romans know how to do this? Did they just luck out? And this gets you to all of the conspiracy theories about visits to by extraterrestrials about that time period, and maybe they brought these technologies and transferred them to the Romans. I mean, we're not going to go there, but
We could go. We could go there.
I
You
guess
know,
Yeah,
the
let's go there. I'm curious now.
I guess the
I think it's
did they just fluke out? Did they just luck out? Like
Paul.
how?
Paul, let me ask you a question.
Yeah.
Do you believe we're alone in the
No, I don't
universe?
think.
You know,
No, I
yeah,
don't think we're alone in the universe. I think the odds of that are very low, actually. Um,
they say there's a trillion universes, and
yes, yes.
I've read Michael Salas' books, which I highly recommend. He's a PhD, regular podcaster, and his show's called Exopolitics. But they
Anyway,
say,
yeah,
yeah.
yeah.
So anyway,
So
first, let's stick to concrete. So
okay, so let me do a couple more minutes, and then let's go to Q&A for as long as you want. So, um,
I want to
I got
present Chem Concrete. I want to tell you about Chem Concrete.
yeah, and then you can talk about that. So a bit more about the microstructure and mineralogy of concrete. The binding phase, like there's all these interleaved connections of what they call cash, which stands for calcium aluminum silicate hydrate. Now, for Portland cement in modern concrete, it's only CSH. It's a calcium silicate water, basically. So they've got the aluminum in the matrix, and over time, the reactions between the lime, the volcanic glass, the seawater, it forms this interlacing cache network, if you like, and then you get all these different crystalline phases, like and these crystalline phases interrupt crack propagation. There's also some recent papers, modern scientific papers, that are trying to figure this out more, and some of them are arguing that the materials that they chose in the Roman concrete built up internal pressures during the curing process, so that when a crack opens up in Roman concrete, the internal pressures within the material self-close the crack. And then that allows and then the chemical reactions can actually reprecipitate lime and so on and calcium and form the strong bonds to close the crack completely. But so there's a whole bunch of things that, the crack propagation is reduced by the minerals, the internal pressures kind of force the crack together, and then the class within the calcium type class within the material, then they haven't reacted yet, so they chemically react in a similar fashion to when the concrete's actually being first cured. So how do we make concrete better? Well, we can try to emulate the Roman strategies, right? We can try these processes to try to make our concrete much longer lived, cut emissions. Now, I just want to talk about some things that we stick in concrete, of course, and I'm talking about rebar or rebar replacement. So the freeze-thaw cycles in southern Ontario are so deadly to concrete because the thermal expansion coefficient is quite different. If you stick a rebar, a steel inside, its thermal expansion is quite different from that of the concrete. Why do we stick it in? Because concrete, of course, is very strong under compression, very weak under tension. So obviously it leads to say, well, can we get materials that have the same thermal expansion as concrete and put those inside instead of steel? Well, there's a number of different things that people have been trying. Like how do we improve steel rebar? Well, we can coat the steel with epoxy, for example, to try to keep the moisture away from it. Because I said, when it starts to rust, that takes up more volume within the concrete and it starts pushing the concrete apart, delaminating, etc., weakening. We can try galvanized steel, so add tin, so we have the steel is less corrosive. Or in marine environments, we often add stainless steel rebar. It's more costly, right? It's the steel with nickel. It doesn't corrode. There's certain brands like 316L or 316LN or 220S, which are used commonly in marine structures. It adds a lot of cost, but it is much more durable in marine environments. There's some we can trickle an electric current through to try to pull away those ions that break that and get reduce the corrosion. We could have a sacrificial anode system where, a material with a better affinity for the electrons is connected so that the steel is protected in the rebar and your sacrificial anode outside corrodes. Especially in high risk structures, bridges, marine applications. We can try non-metallic rebar. And there's materials called GFRP, which stands for glass fiber reinforced polymers. These bars, they're non-corrosive, high tensile strength, lightweight. It's an attractive solution, but then there's different failure mechanisms from them, and it adds cost. Or there's also FRP, which is just the fiber reinforced polymer, not glass fiber. So that's another option. And, we can go to lower permeability concrete. So we can use a lower water cement ratio. We can supplement the cement material with fly ash, slag, silica fiber, silica, etc. And have maybe slower curing so we can get stronger materials, less chloride or CO2 within the material to delay any corrosion on the rebar. Crystalline waterproofing with the admixtures, insoluble crystals within the pores and microcracks. There's different things that people are looking at, but it's a big area of active research because with a lifetime, you pour a sidewalk, and if you have to replace it in a city in 25, 30 years, right? It just the city budget, it costs a huge amount of money to do that. So if we can make it more durable in the first place, not only are we better for the environment, reducing emissions, but our cities don't collapse, right? From our infrastructure costs are a huge amount, and we're way behind in upgrades to infrastructure in many countries. So in the US, for example, how many roads do you go along where the road is falling apart? The steel guardrails along the side are all corroded, and you're dodging potholes, huge wear and tear on vehicle maintenance, right? Trucks, heavy transport, are less efficient. This is all over, and a place like Ontario, we could be a world leader here. The Romans had nicer, warmer weather. They didn't go through all these freeze-thaw cycles, but so we have a perfect environment. If we could get concrete to last hundreds of years in southern Ontario with our climate and weather, and as weather extremes increase, this problem's only going to get more severe. So there's lots of things we can do. It's a very active area of research. It's fascinating. So anyway, I've gone on for long enough talking about my grandmother and the Roman ruins down the street, and perhaps ETs transferring technology to the Romans so that they knew how to build stuff that would last thousands of years, whereas it falls apart in decades in our modern society, so-called modern society. We think we're really smart, but there's some engineering in the past was just phenomenal. We wouldn't have the capability to do it today even. Like try building a pyramid to replicate what the Egyptians did, for example, And some of the, when they built structures in the ocean, huge structures, they're still there. I mean, with sea level change, we're finding different structures that were, cities that were, once above sea level and are now below sea level. And you go, and there's still they were just so well built, some things in the past that, we don't do that today. We're more of a throwaway society, I guess, today. Anyway, I could go on and on, but it's time to hear from Martin and you and yourself, Dante. How did you meet this guy, Martin, anyway? And what did he do?
Dante is a producer that gets involved. So I
And what
didn't
did
want
he
him.
do to bribe you to do this show
Well,
here?
he just offered a good price to produce it. So I befriended him. I forget where we met Dante, but probably through he does comedy shows in Toronto.
Oh,
Yeah.
you
And
do comedy? Okay,
Yeah, we
I'm
do.
taking a comedy course
Really?
in February. It's stand-up comedy.
Well,
Whereabouts?
we've got a couple of characters that you could watch their podcast. Dante can send you a few
Yeah, I'd
Yeah.
love to see
clips
them.
after, now
Yeah.
that he's got your email.
Mhm.
Yeah,
He'll,
it's absolute comedy on Preston Street in Ottawa. They're
Okay,
very
yep, absolute
active
comedy.
comedy
Yep.
club.
Mhm.
And a good friend of mine from high school is Glenn Foster.
Okay.
So he's been very active on the comedy scene
Nice.
for like 4 or 5 decades. And there's a group in England that are using comedy to try to explain climate change to people.
Oh, okay.
They have comedians, and they've been doing this for a few months, and it's very
Nice.
effective, right? I mean,
are you, are you
so
going to use an alias, Paul, or are you going to just be Paul Beck with the
no,
comedian?
I'm gonna I do all my videos, so I'll throw some comedy skits, 7 minutes or so on there. But I mean,
A
it's
man
funny
of his.
because the number one fear that people have is public speaking, and the number two fear is death. So, in other words, if you go to a funeral, the person giving the eulogy would rather be in the casket.
That's a good joke, I guess. You
There you go.
put
I'm
that
working on material. So.
put that one. So on the topic of concrete, I wanted to introduce you to a few things. Your
Sorry, Martin.
self-healing. Go ahead.
Before
You got to
before
go.
we
Please.
get too much, we do have 8 minutes left. So
Okay.
just as a heads up, if you want, we could
Okay.
go ahead
Well,
and start.
when it knocks off, Paul, because my Zoom wasn't
Yeah,
working.
then I'll just rejoin.
Yeah,
Yeah.
and you re-click it. We'll go right
Yeah.
to the end and then click.
Okay.
Yeah, might as well,
Um,
because we might want the time to.
So I wanted to share some illustrations and some information about Chem Concrete. Chem Concrete would be the closest thing to Roman concrete in the fact that it's self-healing and nanotechnology. It's actually a world patent by some really smart Iranian guys. We could get into Iranian jokes, but I think what's happening in Iran is terrible. What do you think?
Well, the water shortage, like they may have to move Tehran. Did you hear about that?
Yeah,
The whole
there's
city of Tehran could move. Like it may have to move northward to have access to water. It's
well,
a huge issue.
yeah. Well, I guess they're just maybe hundreds of feet deep, right? I don't know. There's always water when you go down it.
Yeah, you have to go deeper and deeper. Yeah.
But anyway, Chem Concrete is a very smart group of PhDs from University of Australia, and I've been involved with it, and it's been handy for some of my patents. Like I have a waterproof wall. Can you share one of the files, Dante? I think I can even give you the one that this concrete
Do
actually
you want the
beats
patent
water.
one?
Yeah,
Oh, the
just
bead one.
I gave you five.
Yeah.
So this is Chem Concrete. This is a sample. You'll notice that it's cracked off, but it's just for a sample. But it beads water, Paul. So the key to
Right.
concrete durability is that it is impermeable. Like if you're impermeable, then it'll do this type of thing. That's the nanotechnology within that. So I have a waterproof wall patent. If you were to pour a sidewalk, it would bead water. So, and we have no idea. I would think generally it's long lasting. Concrete suffers from rebar, and a very popular alternative is MST rebar. Bornea has got a 300,000 square foot plant. He sells about 400 million a year. GFRP, so glass bar. So when you get the expansion and contraction characteristics of this to match that, like in the MTO highway world, they flat spec MST rebar. So it's quite cost effective. It's light. You have to hot bend it. But other than that, if it's detailed properly, it's the same cost. So here it is. People are using rebar in your parking garage that needed rehab. It's very likely the rebar and a porous concrete, which could come from adding water and affecting the mix design itself. A lot of people add water to make it easy to push around and finish, but then that water increases permeability. When you talk about the crystalline, which you did mention, that is true, that Crichton and Zypex are billion-dollar companies. They're Canadian companies. They're 30% waterproof. This product is 95% waterproof. And I've done a series of podcasts on it lately. So the Contractors Innovation podcast, I try to get contractors on, and my friend Jim Kaler, who's handling the US, I recommended him actually for the US. He's got Chem Concrete .com.
Okay, well, what I'll do is, I have, I'm approaching 50,000 subscribers on my channel.
Yeah.
What I'll do is I'll highlight,
Maybe I could come on the channel.
yeah, I think we've had you on to Climate Emergency Forum. I generally, for my channel, when we have interview people, I do it through the group Climate Emergency Forum, or another group called Facing Future, where we have guests as much as possible, whereas my channel is just more on the papers and stuff. But what I'll do is I'm also filming myself with my camera what I'm saying today, and I was going to post it up on my channel, and then I'll give all the links to what I'll do is I'll talk about I'll talk about different videos that you've done, that with your channel, and I'll really try to promote it, and you should see a jump in the number of viewers, like for this program on your channel, and also for some of the previous ones. I'll talk about in a separate video. I'll just highlight your channel, and I'll just talk about the different topics that you've discussed and some of the products that you're talking about. And again, it's very important. I mean, my audience is climate change mostly, but also scientists. So they're very interested in anything that can reduce greenhouse gases, and this is a perfect, not only, I mean, there's many reasons to do it, right? Not just if it had nothing to do with climate. I mean, it's going to be a lot cheaper. If it's a lot durable, you can make, you don't have all of these huge infrastructure costs for cities or municipalities, and like there's all kinds of positive benefits. So how do you get the water to be beaded and excluded? And is this a property
Well,
throughout?
that's a cured sample
Right.
that has somebody's taken a water dropper and put it on it. So
Yeah.
normally concrete would suck that water up. It would go
Oh yeah,
right away.
absolutely.
So
It breathes, right? It's porous. Yeah.
we'll make sure you get a copy of this, Paul, this
Mhm.
file. Um, the you must be pretty well bet at the end talking now, eh?
Yeah,
Okay,
2 minutes
so
left.
45
2 minutes,
minutes.
okay.
Okay.
So MST rebar, which the MTO uses, my goal, I told Chem Concrete, I would like to, if you go to chemconcrete.ca, that would be my channel. And I've got a company called CSH Microstructure. We're trying to be the Toronto rep for Chem Concrete. So that'll be, I understand the product very well, but you can actually take a standard mix design and put this admixture in instead of crystalline. Crystalline's $30. This is quite cost effective. And it's 95% waterproof, but it's less money than crystalline. So it's going to take the world market. And the guy's got a world patent. His name is Sam, very bright PhD. He's got a whole team of people, probably 15 PhDs that support, and then all these other countries are opening up now. So it bodes well for sustainability and for the thing you mentioned, infrastructure costs. They're still doing standard rebar in subways in Toronto, 1 meter walls, and a density of 2,400 kilograms per cubic meter. And that's the over design characteristic of our civil engineering today. Okay, this is one of my unique patents. This is actually a game changer, geothermal. The outer annulus is clear stone, and the tubes inside are steel. The connection at the top is for a windmill. But you can see that this is a 30-ton heat-cool system. So using the evaporative cooling power of water, which arguably God gave us, it's 850 BTUs per pound. We can put water into the gravel, and the gravel will evaporate because the gravel's got a void ratio that allows for evaporation. This is one version that's, I call a heavy duty, which can actually be dropped in. Different links. It potentially is my best patent. I'm in the process of selling my patents, Paul, by the way. I'm dealing with some big companies. So show me the second slide, Dante.
Yeah, the second slide.
There's a second email. I sent you a few emails.
Yeah, right
The
here.
second email.
This one here.
Okay, so Martin, while we're still on this picture,
Sure.
So the purpose of this is to anchor a wind turbine.
No, it's actually a geothermal.
Okay, so it's a geothermal. It's to heat a building or something from
Yeah,
geothermal.
exactly. Yeah, geothermal is quite popular, as you probably know.
Right. So this
the issue, the issue
okay.
with go back one.
Oh, was the other one?
Okay.
The first one.
Yeah, just because Paul wasn't.
Yeah, I wasn't clear on what.
So the issue with geothermal is it uses glycol. Typically, you can get a 2.5 ton, 1 to 2.5 ton borehole. You mud drill down with a well drilling rig, and then you have to cement that in because they don't know, they just can put them anywhere. But then you have to put a loop of glycol down.
Right, that's a heat transfer mechanism to bring heat from the ground to your building, right?
Right. So then you end up with and you have to put it through a heat pump, right? So
right, and then they're rated in terms of tons, right? So you say this is a 30-ton system.
So they're rated like 1 or 2.5 ton. There's COP, which is the coefficient of performance. It's the energy you put in to get energy out. Ours is
5 tons. Yeah.
Ours is the COP of 5.
Yeah.
Versus
what are they normally?
2.5.
2.5. So this is a very efficient system then.
Yeah, and the benefit is that with my background is I'm a caisson drill foundation guy. So I'm a civil engineer. And so we ended up designing it so that you could put 5 holes a day in with a large caisson rig, let's say a BG34, maybe a service crane, depending on your prefab or not. So I thought we would show you this and tweak your interest in the. It's very, very environmentally friendly because you're using water. Now it needs about 2.5 gallons per ton per hour, but potable water is not expensive.
Right.
And we actually did a podcast recently on the fan power, like actually getting a amount of air. You'd have a tube that goes deeper than the borehole there, and you'd end up, being able to induce a higher rate of evaporation. I've got some very good engineers that support me on my patents. They're waiting for their commissions after I sell them. But the Andrei Kubanov is a heat exchange engineer, and he does 2 nuclear plants. He's quite good. He's a Ukrainian guy. Grew up in Ukraine. He's lost a lot of friends. But anyway, so 30-ton heat cool, 5 in a day.
You can install 5 a day, and it goes down 26 feet. So how much?
Well, it could be it could be 40 feet, but it's a convenient amount. Yeah. So you'd end up having 30-ton heat cool versus 2.5. A hole that takes a day for a glycol mud drilling rig that goes 300 feet, sometimes 500 feet, might take a day before the time the loop's placed. That'd be good production. Yeah.
So what you're saying is that your system only has to go down a fraction of the distance that a standard glycol system does, and it produces more heat.
Yeah, because of the size.
Right.
So if you look at that 72-inch hole, so that's a pretty big hole
Yeah.
with a 48-inch steel liner, and that the annulus is filled with gravel. So what I do is I take the pressure of that first tube is pressurized. I use a water furnace, so you get about 30, 40 psi, and you just open the water to flow into the gravel, and it automatically cools the returning water or heats the returning water. So you're running it through a water furnace, and so you can set it just like a thermostat.
Okay. Wow.
There's nothing about it that isn't
Yeah.
similar to, but it's just the production and the size, the ability to scale. Like 72-inch hole is a pretty big hole. Typically, you'd be looking to do that in clay, but you could do it. When you go down 5 feet, the ground is 60 degrees, and there's caisson techniques that can sleeve wet holes, take them down. A high water table is not a bad thing, but you have to use the technique that allows you to sink a foundation in a high water table. So I think that you've got that, Paul, eh?
Yeah, no, looks, yeah. I mean, do you see some disadvantages of the heat transfer fluid being water versus glycol? I mean, glycol is traditional, right? Why do they use glycol anyway?
Well, good question. It's not environmentally friendly. Like if you put that in and you nick it or you have a leak, how do you fix it, right?
Yeah.
So there's all kinds of techniques, that result in it being slow. But here we could actually withdraw this. Like you could take this out, ship it
Yeah,
to
pull the
another
whole
place.
thing out to repair or
because
replace.
it's like a transportable.
Yeah.
Like I thought that the way to get the production is to do this version, shop manufacture them, and then put 5 in a day. Like it's going to change the geothermal industry.
Yeah. Oh, yeah. Oh, no, this sounds very exciting. So what was the next diagram that you were going to show?
Go ahead. This
Okay.
is I'm getting my patent advertising in here. Go ahead.
Yeah, no, why not? It's great.
Now this is one of my key patents. It's a waterproof wall. So using Chem Concrete and shotcrete, you might be familiar with shotcrete, Paul. You spray it out of a 2-inch nozzle.
Yeah, I mean they do a lot of work on the LRT transit system in Ottawa and in the tunnels. The shotcrete it's fired like out of a gun almost to stick onto walls and so on. So I do know about the shotcrete. Yeah.
Yeah,
I love the names that you guys come up with for these things, right?
Well, EP18 lock. That's that's what this is called. So I put 2 5-inch layers and I put a wood float on each layer. And I'm using Chem Concrete. So I interlock the layers. Part of my patent is that feather edge that's in finer print to the right there. So no joint lines up. So you'd end up with the ability to truly have a waterproof wall. Now, not visible in this picture is I put a drain board down the back. So what I'm trying to do here is replace secant walls, which are traditional solution of drilling circles in clay. Then they have to put a final wall in front of it, or they have to put let's say they have to make sure their circles interlock properly. It's called a caisson wall or secant wall. It's predominantly 95% of what goes on, maybe more. So the savings is $100 a square foot over a secant wall because the volume of the cementitious is so low. Like I weld tabs on the pile, and the tabs allow me to run a light 15M rebar so I can grab that first layer, and then the second layer goes on it and each one gets a wood float, no joints align, so it'll never leak, particularly with the drain board behind it. This is Toronto put in a bathtub law and it kind of carried its way across Toronto. Everybody follows, or across the country, everybody follows Toronto. But typically, the bathtub law said that you had to assume a high water table, even though Toronto's a glacial till. There's no water. You get about 10 feet of fill that might have water at the bottom of the fill. All the combined and storm and sanitary in an old city is connected. So they're not doing anything by putting this. And so they said, well, we want a raft slab 2 meters thick, as if the building's going to pop out of the ground. I mean, they go down there and it's dry. I mean, we used to just put pad footings in the 80s. So now everything's changed because somebody decided that they didn't want combined storm and sanitary into the sewers at Ashbridges Bay. So then all other cities thought, well, we don't want combined storm and sanitary. We got to do what Toronto's doing. So some of these solutions are going to work well for whoever buys my patents. If they have you have to use good engineers. Like I use Isherwood Associates as one of the top engineers. I've used them for years. They're a 50-year-old firm. I used to know Brian Isherwood, and the person Nader Ansari has taken over. He runs a pretty good shop, and I've known him for years. We've done some great jobs. We did the Skydome together. When I was at Deep Foundations, I did the Skydome. So my company's called Fang. There's a detail of the Fang feather edge. So I think you understand that, Paul. Now,
yes, I do. Yeah.
And I'm replacing blindside waterproofing, so I don't want peel and stick or anything on.
Now, is it just walls, or could you make pipes? I mean, leakage from caissons, concrete pipes and stuff. I mean, we lose what, 30% of the city water? You know, they try to send little robots in to see where the water's leaking out. This is drinking water.
You definitely, this Chem Concrete should be put in every cubic meter of anything. I mean, the beautiful thing about the nanotechnology, there's 5 nanos in there. So, you know, that's the self-healing. And they actually, if you take a typical shotcrete mix, it'd be 400 to 450 kilograms per cubic meter. So you end up actually being able to reduce the cement, which makes the admixture very cost effective. Right. It's actually not that expensive to use the nano. I don't know what the formula is of their nano, but they have a world patent anyway. So
yeah.
The next slide,
great.
Next slide, Dante. It's the next email. I think it should be.
Are you talking about the windmill?
You know, yeah, sure. I mean, there's I sent you five emails.
So this will be
one
the
of them
middle
was
one.
the email. Oh, the windmills are not the email.
So the third one he sent, I think.
Paul, you got a copy for your record?
Yeah, I've got copies of the 5. Yeah, I saw them. You sent them just before we started.
Yeah. So yeah, one of them is the windmill, and then you sent 2 of the.
Can you open the windmill?
Yep.
Just open them in order.
Yep.
Of when they got them.
Here we go.
So that's what goes on top of the geothermal pole. And because there's never been a windmill supported by a geothermal, I got the second patent. The nice thing about this is a vertical access windmill, and you know I've got,
super quiet. You can use it in an urban environment.
Yeah, and
very low footprint, really.
Yeah,
like
no, exactly.
No huge blades. I mean, it's very efficient. Yeah,
you can do 5 and 10 kilowatt. You know where this would come in very handy, which we can move sidebar a bit onto AI. So AI is a big energy draw, right? So the idea would be if you put these around the perimeter of a big AI location, it would work quite well. But I don't see any ground conditions that it wouldn't work in. And then every place is windy. So
well, the thing about these two is you can have turbulent wind changing direction all the time, and the thing still churns away.
That's right.
Whereas if you've got huge wind turbine blades, it can take time for them to, you know, sometimes you got to feather them, and it takes time for them to adjust. Like, so they don't like turbulence, they like steady winds. But these are fantastic for urban environments. There's a lot more little micro wind currents and so on. So
yeah. the cost of that is probably, I got one quoted in like a version 2.0. So this is version 1.0.
So is this a model, or do you actually
No,
have this installed?
I have
Yeah.
that. So I
You,
took it down recently only because we wanted to put up a 2.0. So I have it
yeah.
as a lawn ornament, and I'll send you a picture later, just
Okay, sure,
a
yeah.
lawn ornament. But I'm in Godrich on
Is the
three.
2.0 is that up and running now, or are you in the
No,
process of?
what I'm trying to do is sell my patents, then I'm going to buy one. So,
Okay.
the engineer in Boston, this Matteo Fergoni, he's a brilliant guy. He's a mechanical master's in engineering, one of my key three engineers. The other one is Matt Janes. And then there's the geothermal guy, Andrea. So they all get a percentage of my patents
Your patent, right.
when they sell.
Right.
But he designed that windmill, and he did a really good job on the redesign. So it's basically a kit, right? You can buy it.
Yeah.
It's
Yeah.
like a kit. You got to buy the
Awesome.
pipe. That pipe underneath is called an HSS, but he has a different design for tucking the motor. The motor's behind that FE symbol. It's in there, and it's
Yeah.
mounted. And he's made it so you can keep it tighter, and everything
Okay.
can be tightened up, like almost like an adjustment of a motor.
Yeah, so that, I mean, that's the generator basically for the turbine. Yeah.
Yeah, exactly. It's a high pole magnet.
Yeah, you just run it in reverse. Yeah.
Yeah.
I mean,
Um,
if you could apply power to it as a motor, but it's generating power. Yeah.
yeah, no, it's free. It's free energy. I
And
call
it
this
generates it's generating AC or DC?
well, it'll generate direct current, but it'll be
DC. Yeah.
it's typically a magnet motor. It'll generate it either direction. It'll go
Right.
forward or back, whatever way the wind drives it.
Okay.
And so I think you understand the two
Yeah.
patterns there.
Oh yeah. Yeah.
But
Yeah. No, it's great.
Don,
These
give us another slide there, buddy.
Those are the five that you sent me.
Oh, you sure? What were the you got the concrete sample?
Yeah, with the beading, correct?
Yeah, so Paul, you've got that now.
yeah, I've got them.
So
Yeah.
feel free to share it. It's called Chem Concrete.
Yeah.
And
Okay.
I'm becoming you can almost give them my phone number if they need any of it. Because
Yeah.
I'm going to be
Okay.
I'm going to be the rep for Toronto. The guy who's got Canada is in Sudbury, and they're actually going to do a production run this week. I was going to
Hmm.
have Jim Kaler on my next podcast, but he can't make it because they're going to
Okay,
Sudbury.
great.
So those nanos are going to be assembled. He had an interesting patent for pipe, and he got a hold of he found out about Chem Concrete because he has a pipe for sewage, Paul.
Yeah.
So if you're putting sewage, you could actually use it like a geothermal, right? I think it's a bit of a busy idea, but he wanted Chem Concrete because of its ability to hold intact. And this
Right.
goes to your idea of any pipe, concrete pipe should be Chem
Yeah.
Concrete because
Yeah. Exactly.
it's cost effective. Like you're actually going to use less cement
Yeah.
than the normal mix. So it's a game changer. I often call it the game changer.
I think so. Yeah.
Yeah.
Hmm.
So what else? What else can we talk about, Paul? That would be so Roman concrete. I see posts all the time on LinkedIn. I have 5,500 followers now on LinkedIn. I spend a lot of time there because I'm flogging my patents, and I'm also trying
Yeah.
to be
I'll pay more attention to your LinkedIn. I mean, I don't use it too much. I post all my videos there,
yeah.
but I
Go
don't.
follow
I've
me.
loads of people comment and stuff in LinkedIn, and I'm a bit bad on following up on some of the comments there. But
Sure.
I joined every social media thing going for my channel. So when I do a video, I've got like a routine where, I do the video, I change the title page, I add the description, put a description in the comment as well as a description, and then post on social media like crazy. So starting with X and then, pretty much anything out there I post on. So And I'll be adding more comedy to my routine after
And
if I pass the stand-up comic course. I think it's very good for keeping the audience captivated or entertained or something. I mean, some of my videos can get pretty dry if it's really technical stuff, and I'm trying to show graphs and figures and stuff, and I'm trying to explain it in everyday language. But some of the stuff is pretty complex. It's hard to do that. So I'm always trying to work on ways to improve it, and then any interviews I do is with the group Climate Emergency Forum, and recently I recommended that we do some documentary style things. So, like we had Peter Wadhams, who's the top expert on Arctic sea ice. We had him on our channel, and rather than just have him talk about Arctic sea ice, we talked about his life in science. Like he's in his 80s now. Who knows how long if he'll be around? His health isn't fantastic. And so we got him talking about his work in British submarines, nuclear submarines under the ice. He was one of the first guys to point sonar up to measure the thickness of the sea ice and so on, and how it's
yeah,
changed over the years. But it was more of a focus on him and his life rather than just on a specific thing. And then we had Sir David King, who's one of the advisors to the UK government. And just earlier this week, we interviewed this guy, Brian
are
Holt.
they like group interviews where you have a whole bunch of
There's
people?
myself and a guy, Herb Simmons, that lives in Washington, D.C., and then a scientist, retired scientist who lives in Vancouver, Peter Carter. So we're the main three people questioning, and it's like a Q&A sort of thing, but very informal. And the guy we interviewed this week, it'll be posted next week, is Aldridge. The guy, are you aware in the UK in late November, they had an emergency climate session where these guys organized, they got 1,200 people attending. There were over 100 British MPs and people from all different aspects of industry. And there were a dozen scientists talking about like tipping points and different aspects of the climate crisis, climate effect on the military, climate effect on food. And they had this afternoon session, and it's it's going to be a movie. Anyway, this guy and his brother just decided to organize this thing. So how the hell did they do it? And how'd they get so much buy-in? Because we'd like to maybe duplicate this in Canada and in the US and other countries. So I can send you the link, but again, it goes to it's applicable to anybody. Like how do you get your channel to take off in terms of viewers and interaction and comments and right? I mean, there's certain things that work and certain things that don't work. So, I've been trying to do this for many years with my channel. I mean, I'm approaching the 50,000 viewers, but then there's a channel like Just Have a Think. Are you familiar with that YouTube
No,
channel? This is
no,
a
there's
British guy, he runs this channel, Just Have a Think. He's got like 10 times more viewers and subscribers than I have. And he gets professional editing for all of his videos and his delivery. Like, I don't know. I mean, he's good. I think in a previous life, he was in marketing or something. So, yeah, so that's the sort of question. I'm just throwing that out there to think about how to, like
I
how long, when did you start your channel,
well,
Martin?
this is a recent podcast. I had
Mhm.
another podcast called The Value Engineering Experts, and that got quite popular. It was voted in the top 300 built environment podcasts in
Hmm.
the world. But I think interesting guests are key, and
Yeah,
probably not having excessive length to the podcast.
yeah,
People
I
want
think
to,
so.
so maybe like even these half-hour things. Quite often we can get it done in a half an
Yeah.
hour.
Oh, yeah,
So
exactly. Yeah.
the I would think we're
Yeah, Dante
but and
has a
so
question. I think.
consistent. Go ahead, Dante.
Yeah, just to go back really quickly to the Roman concrete. You said that they found Roman concrete from the Ice Age?
Yeah, so
Well,
let me talk about Roman concrete just for a
yeah,
second,
let's
Paul.
yeah,
So
go ahead.
Roman concrete is very much attributable to the ash. They claim that the ash and the use of compression are key. Like if you introduce rebar, standard steel rebar, you'll get cracks and
Yes.
you'll have problems with rehab. And then if you don't have a impermeable layer of concrete before, let's say, glass rebar, you'll have problems. But if you can imagine, Dante, if something's in compression, those Roman columns, for instance, there was no rebar in there,
Yeah.
and that the fly ash was readily available. I still think they might have had help, but by the same token, it's often stated that the compression, right, and keeping it away from salt water. But you say, Paul, that well, if you're underwater,
Well,
it's
see,
not
this is
going to be a
I
problem because if you're under salt water,
yeah,
you're basically getting there's no oxygen, right?
yeah.
But
Like I don't understand. I mean, we go through great lengths to keep salt out of our modern concrete, and when it gets in, it shortens lifetime, causes corrosion, and causes huge problems, right? And yet the Romans used it and they used it as a key factor in having longer lived concrete. So this is kind of a puzzle for me. I haven't figured out
well,
what's going on.
the rebar is the best answer, and the
Yeah,
lack of
rebar. I mean, if you
and
have
the last
rebar, the Romans didn't use rebar in their concrete.
right.
And the Romans didn't live in southern Ontario. They didn't have freeze-thaw cycles. Freeze-thaw cycles, we used to be a couple times a year in on southern Ontario winters. Maybe less than half a dozen anyway. And that's gone up. Now it can be 20 or 30 freeze-thaw cycles throughout a winter. So that's gone up huge amounts in southern Ontario, right? Depends, of course, on your latitude where you are exactly. But this is really tough on any concrete that has different types of materials like rebar or whatever inside. This is why some of the glass fiber, polymers, threads, if you like. I mean, I think of the submarine that went down to the Titanic, the carbon fiber for making, that submarine I'm talking about, and they used carbon fiber and then they had like 10 or 20 recycles and then it imploded, right?
Well,
Because
I didn't know. Yeah, I've heard so.
there's a
Got a
good Netflix
vague
series.
memory. Yeah.
Yeah, anyway, they went down to see the Titanic and the thing was just crashed and disappeared. There was a search for 3 or 4 days and then they found it. So it was carbon fiber for the shell of the submersible, and going down to Titanic water depths, like the pressure increased release cycles. Every time you cycled this thing, it stressed the carbon composite, and then it eventually just separated, delaminated. Everybody died on the sub. But anyway, there's some interesting. So this will be your next endeavor, Martin. You'll figure out with your materials how to make a submarine out of it.
Well, no, I don't really want to go in a submarine, but it sounds expensive. I probably whoever buys my patents, I'm going to work for them for a few years, and that'll
So
be
how do you sell a patent? You just meet with
it's
people.
not believe me, it's not easy. So because I have a dozen of them, and they're all
Yeah.
related to foundations, I can target those ADSC, American Drill Shaft Contractors, level 1 to level 3 contractors. The company that I'm talking to now, they're the biggest in the world, and they're big in Canada and the US. So I hope to get involved with them. But I've decided, Dante, I'm going to send a package out to two competing firms. One,
Okay.
Green Infrastructure Partners in Canada, and one with a complementary firm called Malcolm Drilling in the States. Both high-class firms, both over 500 million a year. So there's lots of men and a lot of consolidation's gone on in the foundation industry. My old company, HCM, is the largest independent, privately owned contractor in Canada, and they've done quite well with the Toronto and or the Cambridge and Alberta connection. Paul, something I'm going to mention to you,
But before you go on, like on this topic, like like who uses more concrete in the world than anybody else? Which country?
well,
Who's making more infrastructure?
I think
China,
I have a
right?
guess.
China. So are you like is there any way you could market some of your stuff to China? Like is that patent protect carry there or?
I generally patents, first level of patents is the country. So I've got Canada.
Where the patents issued, yeah.
So then I didn't do all my Canadian patents in the US, but most firms work in both markets that are of any size.
In both markets. Okay.
Now,
Just I had to throw that in while we were talking about.
Now, the good thing about Chem Concrete is they've set up Chem Concrete Australia, Chem Concrete New Zealand, Chem Concrete USA, Chem Concrete Canada. They've said it. They're going all around the world because they have truly the solution to Roman concrete. I'm going to say, Paul. I think you'll embrace the learning curve there nicely because you're quite interested and knowledgeable about concrete already. But I was going to try and interrupt you and say, we've got Roman concrete, but it's called Chem Concrete.
Right.
So, and it's self-healing. You were right about that. And it's got to be affordable. I think people get in the habit with Portland cement, just doing the same thing over and over. And, it's driven by the buyer. So the buyer ends up saying, well, I need what I had last time, right?
Yeah.
It's very hard to try anything new. But now that Chem Concrete's around, there'll be a lot of people trying that. Like conceivably that guy's who's created it. It's worth billions, that mix design he's got.
Yeah.
So, because it's cost effective.
8 minutes remaining.
Yeah. Okay.
Well,
Paul,
I mean, a couple of years ago, 4 years ago, I got a dog. Never had a dog. So what I had to do is I had to build some fence up in my property. So I just did it all myself. I did it by hand, dug a deep hole, and got the fence posts and put the wood down and poured in my Portland cement concrete.
I'll give you a quick lesson on. The best way to build a fence.
For next time,
don't use concrete. Just put clear gravel in the hole because the post won't heave because it doesn't have a concrete lip. And that's how I did my deck recently. 6x6 posts.
Now you tell me. Okay.
Yeah,
I should have talked to you.
You'll probably remember that now.
I will.
Yeah, because the gravel drains, right? And it's cheaper. You just have to
what
pack it.
I did when the hole was dug and just before I put in the post and poured, I lowered my phone down into the hole pointing upwards while I was filming a video. And I think I may have posted that on my video channel. So it's perspective, you're in the hole looking upwards and there's this face peering down and all the colors and stuff. It was a very cool video. Anyway, that's just, whatever. It was a fun project.
Oh, I'm glad you mentioned the fence post because the gravel, clear 3/4 limestone gravel is the basis of my geothermal. And it's really a very, very effective because it's self-compacting, right? I mean, you might tamp it with a 4x4 all the way around a hole of any size, but it's extremely robust because limestone is very high compressive strength. But people put concrete around it and then it cracks. Like if you put a fence post in, probably if I went to your fence now, it'd be a little bit lifted by frost lipping.
A little bit off.
And there'd probably be a crack on the corner.
There probably is.
So the water gets in there and then it rots the wood.
Well, you'll like this other project that I did in my backyard. So I was tired of the grass never growing because of all the trees, it gets shade. So I removed 14 inches of topsoil in my entire backyard, except for the edges where there's like plants. And then I got I got like 4 or 5 tons of crushed rock, large diameter crushed rock. And then I went to finer and finer and eventually stone dust. With the top layer was stone dust, leveled it. And then I bought a guy's driveway on Kijiji, his flagstone driveway. And in about 20 trips with my car, I brought all the flagstone and piled it up in my backyard. And then I laid it on top of the stone dust. So my whole backyard is now this, this
Patio, like a
rock.
patio.
Yeah, like a patio, and it's perfect. Although I could have leveled it a bit better is my only drawback, right? Like
You
it's still a
gotta,
bit uneven and bumpy, but
yeah. Well,
anyway.
it's hard to fix it now, but
Mm.
do it right the first time.
Yeah.
You know what a screed is? Screed, like you
Screed,
pull.
yes.
Yeah,
Yeah.
so you should have screeded it. But you
Yeah,
come,
well, the biggest reason for doing it, I used to get water flooding in through the house was built in 1911. The house is like 115 years old. And there used to be water coming in. When I bought the house, it was pouring that week back in 2006. And the water, I could literally see water coming in through the foundation, through the walls in the basement. So the drainage wasn't, but I basically put a huge French drain in my backyard with
yeah,
my excavation, and now no water problems, never have water problems again, right?
the
Because
key,
so
you probably could have done it just with gravel and
yeah,
just screeded the gravel, packed it,
yes,
like proof road it, but you don't really need the crusher. The crusher
yeah,
gives you the fines, and that's hard to work with, right?
and more
Compared,
expensive, I guess. Yeah.
yeah.
Anyway, that was good exercise, that project. So
We
Anyway,
just
Paul,
over 3 minutes.
well, okay. Well, anyway, I appreciate the opportunity to talk to Paul. And if you're still listening, please press like and subscribe. We need lots of subscribers in the future, Paul. So any help
yeah,
I'm gonna keep doing it. We're doing one a week,
yeah,
and
no, it's great.
they're
It's
gonna get very interesting. Some of the guests are gonna be very interesting. So if you subscribe, that would bring us.
Yeah, I subscribed, and I'll try to promote what you're doing on my channel, and we'll have you on. I believe we had you on Climate Emergency Forum a while back, and we'll do that again. We'll do a follow-up with some of the new work and stuff that you're doing.
And
Um,
maybe we can just talk about Chem Concrete again. I
yeah, yeah,
consider
exactly.
myself
Sure.
a bit of an
Yeah,
expert. I mean,
yeah. No, we'll do
we
that, and let me know anytime you're visiting Ottawa. We'll go to the pub or something.
sounds good. I don't drink anymore, but I'll buy you a beer.
Yeah, well, coffee then or whatever.
Yeah.
Great, some great. There's a new coffee shop in my neck of the woods. It's called Sophia's Vintage Motor Cafe. It's a oral surgeon, so a dentist. He collects exotic cars. He has for many years. He stored them all in a warehouse, and then he decided, well, people should see these cars. So he bought an old bank. He put in bulletproof glass and stuff, and it's a coffee shop, and all of his cars are just parked. So you can actually go and sit in his Fiat and have coffee. He took out the front seats, put in a little table. So you can go into the coffee shop and you can sit in the Fiat and drink your coffee. Anyway, really cool place. It just opened a couple of months ago. I bring all
That,
my visitors to Ottawa and friends there to
oh, yeah, when the spring comes, the
yeah, so
weather.
let me know when you
It's,
come when you're planning a trip. Yeah.
hey, we didn't talk about the pole shift, but that's probably, yeah, I talked to you about it earlier, right?
Yeah.
We could do an episode just on the pole shift. I could send
Yeah,
you.
I'm actually looking into that. I'm researching
There's
that.
some very good podcasters, eh?
Yeah.
That
Yeah, there are. There's some excellent stuff out there.
like a lot of
Uh,
people think that the geoengineering, which is ongoing, I only recently discovered, is because of the pole shift. I always thought it was climate change. And I'm
Just
sure,
we have 1 minute remaining.
okay,
yeah.
anyway, I'd just like to say
Yeah, so
God bless everybody. God bless to you, Paul. And
Yeah, okay. Well,
I
thank you
always,
for having me.
I,
It was great. Yeah.
I'm glad you brought your dog. See ya.
Yeah, he's Newton's there. He's the smart one. Okay. All
See ya.
right. Bye, everybody. Thank you.
Bye-bye.
Baby, I need to know